Hi guys, another question from section 4.5 is number 29. So we have integral of e to the t dt all over 3 plus e to the t, okay? So again, we're asked to use the integration by substitution method. Let me tell you, when I look at this problem right here, the first thing I notice, we do have a function. Obviously, these are all function of t. We do have a function in the denominator. So usually when you have a function of whether it's x or t or any variable in the bottom, always remember this rule that usually can be applied. That says integral of du over u is natural log of absolute value of u plus c, okay? So if you remember, we had this rule that it says integral of dx over x is natural log of x, except this also works when you have any function of x. Again, don't forget, when you have a function u, you must get the right du, otherwise you can't use this formula. So as soon as I saw this function down here, it reminded me of this rule that anytime you have a function downstairs, you might want to apply this rule. But of course, to apply it, you have to once again choose the u. Of course, there's only one choice for u, since u is supposed to be in the denominator. So we'll go ahead and choose u, and then of course hold our breath for du. Because if you don't get the right du, obviously we can't use this formula, okay? So first thing is choice of u, which is the only obvious choice is 3 plus e to the t. Now, what's du? Remember du again, differential of u is the derivative of the function u. Well, derivative of 3 is 0, derivative of e to the t, as you remember, is the same thing, e to the t, and don't forget times dt. And this is what you call a perfect match. Look at that, e to the t dt, e to the t, that's exactly what you wanted, which means now you can replace that by what it is equal, which is du. Of course, this is what we call u, and there it is. There's your perfect match with this rule. So we're going to go ahead and let me start it from up here. So now we can rewrite all that in terms of u du. So again, e to the t dt is the same thing as du in our case. And then of course, 3 plus e to the t is what we called u. And there it is. There's your beautiful match. There's your same expression. So now we can apply the rule, which says this is the natural log of absolute value of u plus c. But don't forget the last step is to go ahead and change the u back to original function. Of course, u is 3 plus e to the t. So final answer is natural log of absolute value of 3 plus e to the t. Because remember, that was our u, right? Our u is 3 plus e to the t. And then plus c. Okay. Now, the only other thing that I will tell you in this case, this may not be a very big deal, but sometimes the book does use that idea. So you remember, natural log of, anytime you have natural log, you have to have absolute value, because from your algebra, remember, you can't take natural log of a negative number. But if that expression inside the absolute value is always going to be positive, then of course you don't need the absolute value. So absolute value is there to make this positive. But if it's already going to be positive for every value of t, then you don't need the absolute value. And as you remember, e to the t, of course, can never be a negative number. It's always going to be positive value. Of course, you add it to 3, it's also positive. So in this case, you can leave the absolute value, or some books, of course, once they recognize that expression is positive, they actually drop the absolute value and just change it to parentheses instead of absolute value. Okay, and that's the option, but you can do it because not every case. In this case, because this is always positive. If you weren't sure if this is positive, you would have to leave the absolute value always there, okay? All right, so this is the next problem. I have one more video for you to make, because there is another question, and then I'll stop this one and make another one for you, and then hopefully upload this shortly.